Let us start, guys. What is a virtual environment and how to create it and why to create it? Okay. So first thing we are going to learn, how to create a virtual environment and how to, activate it. Let's suppose this is a PyCharm, interpreter, and in that this is called as guys terminal. Here this is a terminal. Okay. In this terminal, guys, there are a lot of, ways. Let's suppose, here you can support, you can search Word, Windows PowerShell. You can have this command prompt. You can have that git bash. So there are a lot of options here. Let's suppose, Windows PowerShell, and then I can also select something called as command prompt. And then what we are going to do is, guys, creating a virtual environment. Virtual environment means an environment specific to that particular environment. Let's suppose Python, 3.10. Okay. So I want this version to a particular, environment. Let's suppose I take a Python version 3.10. So if I create a virtual environment, it will have Python 3.10. If let's suppose I take 3.11 for a particular environment, then it will have Python this version. Similarly, other softwares. So we have to create a virtual environment and then activate it to have a particular, configuration. So how to create a virtual, environment? There are steps which we will follow and we'll create the virtual environment. So this is the guys, simple, code Python, minus, M and then V environment, and this virtual environment name, you can give any other name, but generally most of the company follows this only V environment underscore name. So once you click enter, guys, what will happen is that your virtual environment will be created. So my is already created, guys. In case, if it is not created, then how can we, create? Let me just first deactivate it. Then I can, show you. Let me just deactivate it. So let's suppose this is a, path. C uses Dell PyCharm project and PySpark. It's not a virtual environment. Virtual environment means you should see, dot V environment. This means you are using the virtual environment. So how to do that virtual environment is that first you have to give this particular guys, command. There is nothing but Python minus M V environment and the virtual environment name. Let's suppose this is the command. You give an enter, and then one virtual environment is created. Okay, since this is blinking here, and then you can activate it. So let's suppose we want to activate it in command prompt. Then whatever the virtual environment name is, the script activate. Let's suppose it is PowerShell. Then we have to use this one, dot and then virtual environment script activate dot ps1. Let us just try this one. Okay, because this is window PowerShell, and give an enter. So this is what is the virtual environment created in Windows PowerShell. Let me just try to create it in command prompt also. Okay, so let us just take our deactivate command. It should be very specific. Okay, let us just take this command. So now see, this is just a path, guys, where this is written C uses Dell PyCharm projects PySpark. In command prompt, I want to create a virtual environment. Now to create a virtual environment, guys, we have to give the command, same command, Python minus M and V environment and then virtual environment name, and click on enter. So one virtual environment will be created. Now to activate this virtual environment, what will happen is that this is in command prompt. So this whatever the virtual environment name is there, dash and then script and then dash activate. So this virtual environment will get activated, and click on enter. And now you see here, this virtual environment has come, and here we will write about the commands. Any doubt, guys, how to create a virtual environment and how to activate a virtual environment? Yes or no, guys? Are you clear with these steps? Juhi, Prashant, and Sushmita. Yes or no, Yamuna? Any doubt? Sushmita, are you clear with how to create a virtual environment and how to activate it? Yes or no?
Yes, Vikram.
So, guys, this is very simple steps you can follow and you can create a virtual environment.
Vikram, in my PyCharm, I'm not seeing this Windows PowerShell and command line. Only terminal local it's coming.
Are you clicking on this terminal and then are you just you are going to the local, but let us close this. Are you going to this drop down?
Yep.
So there you are getting the option of command prompt and Windows or PowerShell. Are you not getting?
Yeah. So we need to add it, right?
Yes, you have to select it like a drop down. Let's suppose I want to select the command prompt, then I'll select here. Let's suppose I want to select
Got it.
the
Got it.
Windows PowerShell. I'll select here.
I got that. Thank you.
Yeah, guys. You should ask guys any questions, I've always, entertained you guys. So please, don't hesitate. Okay. Let us just go to guys, some components are there of PySpark. So to understand, let's suppose Spark context. So what is a Spark context? So this is actually the entry point for the Spark in Python. Okay. So it is entry point for Spark, guys. Any, Spark session we create to write any Spark code. Just give me guys 1 second. Yeah, guys. So I was telling to write any Spark code. See, this is the entry point. Okay. Let's suppose there's a line and racers are going to run. So there's an entry point, and after that entry point, everyone will run, and then there will be a winner which is declared. Like that, guys. Spark session we create so that we become a entry point for writing all these Spark activities. This is called as guys Spark session. This is the entry point for all the Spark functionality. Spark context is the entry point for Spark in Python. So it will connect the PySpark application to the Spark cluster. Okay. So it will, guys, it is when I will teach you the, the architecture of Spark, you will be more, getting clarity what is doing Spark context and what is doing Spark session. As of now, guys, Spark session is the entry point. I told you as the racers are there who are running. So in that, there's a line which is created. And after that line only, everyone will start, take their position and then they will run and then they will go to source to the, the final destination. That is called Spark session. Spark context, it will connect the PySpark with the Spark cluster. So what is this PySpark? I have already told you. Spark cluster is group of computers. So this is what is the it is connecting this PySpark application to that Spark context. RDD, guys, RDD data frame, Spark SQL, these things we will see, guys. RDD is nothing but low level because there are more number of codes written. Data frame is high level, collection of objects, which is very very high level. It's in the form of table. It is in the form of rows and columns. We'll see all this thing in detail. Spark SQL, guys, let's suppose someone is very good in, SQL. So instead of writing the, PySpark code, he can, just use, Spark SQL and he can use, simple, SQL and he can, write all the PySpark codes. So we'll discuss that also. It is used in guys, machine learning library and, Spark streaming. Spark streaming, we'll see that the data is getting loaded for, source to target. That is nothing but, Spark streaming. So these are, guys, some basic components of PySpark which I have, written. This you will get more clarity when I will teach you the architecture. As of now, guys, Spark session is entry point. Spark context is, connecting this PySpark with Spark cluster. RDD is low level, distributed collection of objects because there's more number of codes written. Data frame is having tables like structure, rows and column. Spark SQL, we can directly write, SQL queries. There, machine libraries is used for, guys, machine libraries. Spark streaming is, guys, whenever we want to process the data, that ETL, we do source to target. When we want to push the data, that is done by, guys, this Spark streaming. So these are, guys, some basic components of PySpark. These things more we will understand once we start, executing and we create a data frame and we'll see these things. So, yeah, tell me, guys, please, mute those who don't have any doubt. No, please mute. So common use is, guys, for ETL. What is the use of, PySpark is for extract, transform, load, large scale, data processing, and for machine library data analysis using SQL. These are the, use of your, guys, this PySpark. How to install PySpark? Just write here, pip install PySpark. Let us just try pip install, PySpark, and this should get, guys, installed. Let us just install. So this is in my system, it was installed, so it's telling upgrade. Okay. So this is very simple for PySpark installation. Once you install this, Spark, Java, and Python, this is just, pip install, PySpark you write, and this will get installed. This is PySpark is getting installed, guys. Any doubt how to install PySpark, guys? This is just a command, pip install PySpark. Yeah, guys, tell me. Any doubt till here? What is, basic component of PySpark and, what is the common use of, PySpark and how to install PySpark? Any doubt, guys? No doubts. Let's proceed further, guys. So let us just go to, guys, there's something called a Spark architecture. Let us just, try to understand what is the Spark architecture. So this is, guys, somewhat Spark architecture is for our understanding. We will know, guys, what is Spark architecture. So we should have some understanding that how the inside this Spark, how is the architecture. So it follows, guys, something like, master slave kind of, configuration. So ultimately, Spark is doing what? We are having the input and it is processes it and it loads it as an output, like your ETL, your Informatica tool. What happens in Informatica tool? There's some data and it gets transformed and then finally it is put to the output. That like that only Spark is there. So it's a processing engine. So there's an input, it will process and it give at the output. So Apache Spark is an open source distributed computing system designed for big data processing and analytics. So we'll try to understand, guys, what is this architecture. So most of the books and pages follows this, architecture. So there is something called as, guys, master slave architecture. So here there will be a driver program, there will be a Spark context, there will be a cluster manager, worker node, and there will be so many worker node. So I have written we have a master node and a multiple, guys, worker node. So there will be a master and there will be multiple, worker node. So cluster manager is, a group of, machines, group of, computers. So that will, manage the, resources in the sense, how much, RAM is required, how much hard disk is required. That kind of, resource management will be done based on this cluster, manager. The name is only manager, so
The
manager will
cluster you
manage.
meant to say here is server backup or servers?
Tell me.
No, cluster mean here just a machine or like any servers with this.
No, multiple, computers. Let's suppose, cluster manager means, you can understand this is a, this is a, this is a, one second, guys. This is a computer one, computer two, computer three, and computer four. And these are, all joined like this. And this is, our master. Okay, this is our master. So this four we will call it as guys, cluster, this four we will call it as cluster. Why cluster? Because there are multiple, computers. This is, computer one. This is computer two. This is computer three. And this is computer four. So this is, cluster manager, which is managing all the, nodes. This is also called as nodes, this computer. So this is cluster manager, which is managing all the, computers. So guys, this is, guys, master slave architecture. We have a master node and multiple worker node. These are, guys, worker node. As I showed you, these are, guys, worker node. These are nothing but your computer. And this is nothing but your cluster manager. This is your cluster manager. So cluster manager is group of machine. Cluster manager will manage the resources. That means they will manage this computer, how much RAM is required, how much hard disk is required. This will be done by this, CM, cluster, manager. Now what will happen? We have, code or application. Let's suppose there's a code written in Python or, a jar is there. So what will happen is that driver manager, this is called as, guys, driver manager. It will call the main method. So let's suppose in a Python, there's a main method. So it will call the main method of the code. And this will, guys, create the Spark context. This driver program calls the main method of the program and creates the Spark context. Spark context is again, let's suppose this is a CEO, driver manager. It has created this vice president, Spark context. Vice president talks with, the manager, cluster manager. Okay, Spark context, interact with cluster manager. So Spark context will request the cluster manager for resources, computer, and, memory. So this vice president told this manager, I require the, resources in the sense computer, and this, memory. Okay. So compute, guys, CPU processing power, number of CPUs, cores available, memory in the sense RAM. So cluster manager will give this, kind of information. This manager will give this kind of information to this vice president. When the nodes are available and when we can, execute our code. So when the computers are available and we can execute our code, cluster manager resource allocation information will be provided. Cluster manager will provide the resource, allocation, which computer is free and which computer you can use it. The Spark context will, again send the code and the data into the particular node. So this Spark context will send the, data and code to a particular, worker node. and then it will, and try to execute the code and process the code. After processing, worker node will, send the result to Spark context. After processing, worker node will, send the result to guys, this Spark context. So these are guys, overall, Spark architecture. You have any guys, doubt in this? You can just, ask. Let me just, reduce the size of this one. This will, yeah, tell me guys, any doubt here? So this is driver program. It will call the main method and it will create the Spark context. The Spark context will ask the cluster manager for the resources. The cluster manager will go to the worker node and it will provide and you see which are the nodes available. To send back the result to the Spark context. Spark context will send the code and data to the worker node, which will get executed. This is overall guys architecture, master and slave architecture. These are slaves. Okay, this is the master. So I told you it follows the master slave architecture. We have master node and multiple, worker node. Cluster manager means it's a group of, machines, the group of computers. So we have code or application, we have Python code or jar, whatever the codes are there. So driver program, what will do, it will call the, main method of the code. Driver program will only call the main method and it will create the Spark context. If Spark context will interact with cluster manager, and it will ask the resources, and then what will happen is that cluster manager will give whatever resources are available to the Spark context, and finally Spark context will send the code and data to the particular node and try to execute that, and after processing the worker node, and the result will be sent to this Spark context. This is guys the Spark architecture, the most simplified way, guys, I have told you. So this is overall. Guys, tell me any doubt here. See the, lines. Let me know if you have any, doubt. Study the 9 points, guys. First is, follows master slave architecture. We have a master node and multiple, worker node. Cluster manager is, cluster. Some cluster means what, guys? Is, multiple computers are joined. That is called a cluster. And that will manage the resources. We have, it's, let's suppose, let us write like this. Let's suppose, let us, suppose, we have a code or application. Okay. So what will happen, guys? Uh, driver program will call the main method of that code and create the Spark context. Spark context, this will interact with cluster manager, ask the resources. It will provide the resources to the Spark context. The Spark context will send the code and data to the, worker node, and it will try to process it. And finally, worker node will give the result to the Spark context. Any doubt, guys, here? Susmita, are you understanding? Joey, yes or no? Yamuna? Uh,
Yes.
this is, guys,
Sir, what is executor or a cache?
these are guys,
Yeah.
executor is, last element which will execute the, particular code. Cache means that, the history will be saved there. I have given these definitions, guys. If you have any confusion, you can just go and study from here. Let's suppose driver program. It will call the main method of the application and create a Spark context. Spark context, it will interact with the Spark application, cluster manager, resource allocation. And then guys, worker node, these are machines in the cluster where actual computation will happen. Executor, this will run the individual task, in a Spark job. Task, the smallest unit of work sent to the, executor. Cache, executor can cache the data in memory for reuse. Cache and cookies you have seen in browser, no? Like that, guys, cache is here, whatever data is getting processed, it will have the history of that. That is nothing but the cache is. And task, the smallest, unit of work. Executor, this will run the individual task, whatever is sent in that Spark job. That is nothing but the executor and cache. Tell me, any more doubt? This diagram, guys, you have to, keep in your mind. Driver program, Spark context, cluster manager, worker node, executor, cache, task, and then again worker node. To explain, if someone asks you guys, Spark, architecture. Any more doubt? Sushmita, Juhi, are you understanding Spark architecture?
Yes.
Yes, Vikram.
Yeah. So guys, there are guys, there's something called as guys, some more, theoretical things. Let's suppose, what is lazy execution in Spark. So lazy execution in Spark does not, execute operations immediately. So let's suppose when you define, let's suppose select, filter, etc. Instead, it will build a plan, and then that plan is called as DAG, directed acyclic graph, and only execute the plan when the action like show, collect, count is called. This is the lazy execution in Spark. Lazy execution means in simple, I can tell you like that if suppose there is a command called as select, okay, there's a command called as filter, okay, and then what will happen guys, it goes something to the let's suppose some lazy person is there, we tell you to select or filter, okay, then what he lazy people, what they will do, they will make a plan, okay, they will make a plan, and this is a plan which is made, okay, and based on this plan guys, first planning is made, and then let's suppose a master comes, okay, let's suppose it tells what count, this is a action has come, now you have to count, or you have to show, this kind of methods come, then only this selection and filter, and then you will get the output. This is called as guys lazy evaluation. The output you will get is what, only when you occur this kind of actions. If you don't occur this kind of actions, there will be a plan only. This is called lazy evaluation in Spark. That is what we have written here. See, lazy execution means Spark does not execute operation immediately when you define like select, filter, etc. Instead, it builds a logical execution plan, directed acyclic graph, and only execute the plan when an action like show, collect, or count is called. This is guys, transformations. These functions do not, immediately execute when called. They build up a logical plan of operation to be executed later. The deferred execution allows Spark to optimize the entire plan and before running any operation, which improves performance and efficiency. So these function guys will not execute, immediately. It will be, lazy. These are called transformations. And this is the transformations guys, which will not get, executed immediately. And function that trigger this execution, this is called actions. This function will trigger the execution of the accumulated transformation. These are actions guys, mainly collect and count will be used guys to trigger this lazy evaluation, and so take, first, write, save, for each, reduce, save as text file, save as table, head, describe. These are called guys action. This function will trigger the execution of accumulated transformations. These are the trigger. This will trigger the execution of the transformations, and this is called as guys lazy evaluation. Lazy evaluation, as I told you, what is lazy evaluation? Means lazy execution. That means the Spark does not execute operations immediately when you define the transformation like select, filter, etc. Instead, it will build a plan that is called as directed acyclic graph, and only execute the plan when an action like show, collect, and count is called. This is called guys lazy execution in Spark, and function that defer immediately. That means it is a stop button I have written. That means it will not get executed immediately, guys. It needs this action. This is a green button I have written here. So action means what? This function will get triggered. The execution, whatever the transformations were there, that will get triggered only via this actions. Be it we collect, count, show, mainly collect and count and show, which we will use, and then only this transformations will get executed. So that is what is guys lazy execution. If someone asks you what is lazy execution in Spark, you can tell that Spark does not execute operations immediately when we define them. Let's suppose select and filter. Instead, it will build a logical plan that is called as DAG, directed acyclic graph, and these plans will get only executed when an action like show, collect, or count, etc. is called. This is called lazy execution in Spark. Any doubt, guys? What is lazy execution in Spark?
Sir, what is DAG? Direct
The directed acyclic graph means let's suppose it keeps each and every steps. Okay, so let's suppose we have written a select with a filter. Okay, then what will happen is that it keeps each and every steps of that particular code inside it. Okay, and then what happens based on that, if there is any fault, then it can just go to that particular particular line where there's a mistake. So that is what that every steps it is keeping in itself. That is called as directed acyclic graph. More overall, it is it will make a graph, okay, based on the code what we are writing. And then what will happen, the every steps it will keep it within itself. Okay, let's suppose we have taken a select, or we have taken a filter, or we have taken a group by. Okay, but that will get executed only and only when this will have that action. So I will guys teach you. There is something called as, let's suppose, DF means data frame. Okay, let's suppose there's a filter. Okay, filter means I will teach you all these things. Let's suppose just just I'm writing some code, guys. Just let it be like that. Okay, don't try to understand. I'm just telling you. Let's suppose this is a code. Okay, A equals to this one. So this A dot show. Okay, when I write this A dot show, let's suppose this is a small letter A. Okay, so this particular piece of code. Okay, this is a transformation, guys. It will not get executed immediately. Okay, so this is called, guys, a transformation. Okay, and this is called guys the action. Okay, and then there is something we will tell DAG. Okay, so it has created a plan. What is the plan, guys? First we will read the data. Okay, and then we will filter the data. Filter the data for the age greater than 20. Okay, then what we'll do, we will select the age. Okay, let's suppose, and then in the last we will what, show the data. So this is a plan which is created. Okay, so every step, let's suppose read the data. Okay, and filter the data. So every step is guys a particular we can tell it as a node, a particular step. Okay, and then guys this is the direction. This is from left to right. First we'll go read data, filter data, and then select data, and then show data. This is a kind of plan we have created. This is called as a DAG. So this will help in something called as, there's something called as, guys, fault tolerance. That means let's suppose we got some step failure. Then what will happen, Spark can let's suppose some step is failed. Okay, so what will happen, Spark can Spark can I can tell you Spark can correct that particular step. Okay, correct that particular step. Let's suppose this filtering was filter had a mistake. So we don't have to correct the entire code. It will just go and just check this one, this particular step, or we, instead of select, we have not written the select. So it will just correct that particular step. That is called as, guys, fault tolerance. So this helps in guys in fault tolerance also, this lazy evaluation. So this is called, guys, this is called, guys, one second, what happened? This is called, guys, DAG plan. Let me just open. It got suddenly closed. Yeah. So I was telling this is called, guys, fault tolerance. Let's suppose some step is getting failed, then it can go and then see that particular step, and then it can just correct that particular step. This is called, guys, DAG plan. This is a plan which has made, Spark is making that inside it. These are called, guys, transformation. This will not get executed immediately. Will get executed only when this action is called. Tell me, any more doubt? Guys, Susmita, what is lazy evaluation or lazy execution in Spark? Guys, are you there with me? Yes or no? Juhi, what is lazy execution?
Yeah, means Spark does not execute the operation immediately. First, it will plan.
Okay, so and then when it will execute it? Only when the actions are called,
Show
like
count.
like your show, collect, and count. Yes or no? Spark
Yes.
will not execute the transformations, guys. Let this filter is there, select is there. All these things will not get executed. It will keep for itself, and it will create a plan. Okay, simple. And then it will get executed when action like, show, collect, and count is, called. Yes or no, guys? That is called lazy execution in Spark. That's all. Any doubt here? Lazy execution helps in, guys. What is the advantage? You can tell it in fault tolerance. Let's suppose some step is failed. It has all the plans, so it can go and just, correct that particular, step. That's all, guys. The theoretical things are, enough for, Spark and PySpark. Let us just, guys, create a particular, data frame and try to, understand how to create a data frame. And let us go and learn some, guys, kind of coding. And let us just try to, understand what is happening. So let me just, start, guys. So this is first line of, let me just, write down the code so that, you understand slowly. First code, first data frame I am going to create. So please, pay attention and just, ask as many questions as you want. And this is, guys, the actual coding I'm, starting. Please, ask whatever you have the doubts. Yeah. So this is the code I'm going to learn, execute, guys. So this is from, this is a PySpark module. From there, I have imported this Spark session. Okay. And this Spark session, we have to, this is the, I told you a Spark session we have to create is an entry point. And if you don't create a Spark session, you cannot use any functionality of Spark. So we have to create a Spark session. So how we create Spark session dot builder dot app name, whatever name you want to give. Let's suppose I've given Python, PySpark example, and dot get or create. This is the syntax. Okay. This is the column name. Let's suppose this is a role. This is a description. It's in a list format. And these are the data, guys. So let's suppose data analyst, and then the description is this one: analyze data, data engineer, design, build, and maintain, data scientist, DevOps, data architect. So all these positions you can know if you become if you know PySpark. Okay, you can become anything. Become a data scientist, data engineer, data architect, data analyst, anything. You can understand how much powerful is Python and PySpark. So this is, guys, the data. Okay, this is, guys, the column names, and then this is what we have created as Spark session. This is what we have imported this Spark session. Now we are going to create a data frame, which is like a table. So the method is what formula is Spark dot create data frame. This is the method, guys. Spark dot create data frame. Pass the data here, whatever data is there, and pass the column names, whatever column names are here. And then once your data frame is created, you want to see it. So data frame dot show. Let us just execute this, guys. So Spark sessions will take time because it initializes this Spark session, then it creates a data frame. So it will take a little bit time. Let us just see. So what will happen? A table like a structure will come, which will have two columns, name and age plus. Yes or no, guys? No. Hold on, guys. We have to execute the main page. We are we have to execute the current page. We were executing the main page. Let me just we execute it because we want a data frame which needs to be created. It should have two columns. One should be role and one should be description. Inside this role, it should be all these rows. Inside the description, all this description should be there. That is what is the data frame we are going to create. So let us just see. Yes, this is the data frame, guys. This is the role, and this is the description. This looks like a table, and this is these are the rows. These are the guys description. This is the first data frame we have created. Entire thing is based on data frame, guys. Let me know if you have any doubt in creating a data frame from a list.
Sir, what is the
Vikram, we
difference
don't.
between SQL table and data frame?
So the difference is that you cannot, use it like that. Table has a, separate, select and update, and SQL commands are there, right? So you don't have to, you cannot, use that, select and update and select queries here. Okay, this is the first difference. At the same time, guys, this is, I have a separate set of commands, guys. Yes or no, guys? You cannot just call it as a, a particular, table because it is having rows and columns, but we can it is, a program which is written, and having, distributed computing of data, because I told you we use it to what? We use it to distribute the data. When a huge set of data are there, let's suppose 10 crore or the records are there, then we can, distribute it, and then we can organize it in the form of rows and column. So it will use the language like Python, and then it can use the other languages like Scala, Java, okay? And it can also have the, libraries we can use of Python, let's suppose Pandas, okay, and then NumPy. So these are, guys, the differences, okay? But wherever, whereas, if you take a table, RDBMS, it is, only managed by, SQL, okay? And that is the, guys, main difference, okay? Data frame will, live in the memory, guys, in the RAM, okay? And table, it lives on the, guys, storage. That means the hard disk, okay? That is also a difference, guys. So, but the schema level wise, both are same only. It has rows and columns, but there's a differences, guys. So first of all, differences, guys, we can use, in a data frame, we can use the languages like Python, Scala, Java, okay? This is the first difference. And in table, we can only use SQL. Next difference is data frame, guys, it will do the processing in the RAM. It will not do the processing, guys. It is not stored in a hard disk. Like table will be stored in the hard disk. It is not stored in the hard disk, guys. It lives in a memory like RAM, and temporarily, it is a temporary use until we are, using it. So these are, guys, differences between a table and a particular, data frame. Tell me, guys, any more doubt? Second doubt.
Vikram, we don't have to define the data type here, right? Like integer or string.
No. Those things you don't have to, define. Those things, you don't have to, guys, define that particular, that what is that, column name, and what is the, table name. So those things, guys, you don't have to, define that. Okay. So we will, see that, when I will teach you there's something called as, schema. Okay. So how to, get that, schema, and that what is that struct type, and all those things, guys, we will, see. But as of now, guys, we don't have to, define that. Let's suppose, df dot, print schema. Okay. So this, you don't have to, guys, define this particular, schema. Okay. And it, takes the schema, and what is that struct types, that also I will teach you. But as of now, the answer to your question is we don't have to define the schema. Tell me, guys, next question. Tell me. See, Juhi, you're telling, no? See, the schema has come. You are able to see that. Let's suppose that is a
Yes.
role is a string type. Description is again string type. Yes or no? And this is the
Yes.
schema. We can see using that there's something called a print schema method. We are just, seeing this schema. But we have not, defined that schema. Tell me, guys, any more doubt? How to create a data frame from a list? Tell me. Everything is based on
Sir,
this
what
only, guys.
is
Huh.
dot app name?
A dot app name, because when you're going to next lines now, so that is why this backslash is coming. Let's suppose you want to take it in a one line only, remove this, remove this, backslashes. Good, guys, you are asking questions, you are also getting some interest. That's fine. When you go to next line, that's backslashes came. Let me just, execute this. This is a formula. So we have to remember spark dot builder dot app name, the application name, which I will show you guys how the, internally the Spark session is getting created using 4040 host, and then the name is coming. I'll show you that only. But, that will be only at the time of execution. But this is the formula. Tell me, guys, any doubt? Next.
PySpark SQL module means what? From?
PySpark SQL module. Okay. This is, guys, this Spark session module means what? Any, Python page which is having all the codes that I told you as a module. Let's suppose this is a page whose name is create PySpark dot, data frame. So this is a module. Module means what? This is a Python page which is whose name is create PySpark data frame. So I create another Python, page. Okay. In that I can write from create PySpark data frame import. Let's suppose there's a column name. So I want to import this column name. So this is an inbuilt, module called as PySpark.sql, from where, we are just, guys, importing this, a Spark session. So this is the inbuilt, module in the sense it is having its own classes, its own function, its own code, from where we are, importing the Spark session. This is a mandatory line. If you don't write, what will happen? What will happen? It will never execute. So you will get an error. And even, if you don't use this one, no Spark session, it will be in gray color. See, this is in gray color because you are not using it. As soon as you start using, it will get, white color. That means from this, module means predefined, classes and codes are written. From there, we are importing this Spark session. And then what will happen? We'll create a, guys, Spark session. As I told you, this is an entry point. What is the entry point? What is the formula? Spark session.builder.app name. Give the application name dot get or create. This is the Spark session you have created. This is the column names. There are two column name, role and description. This is the data, guys, whatever the roles are there, and then we have given comma, which are the descriptions are there. Now to create the data frame, this is the first formula. What we are doing, we are taking the Spark, and then we are giving a dot create data frame method. We are using create data frame method. In that, we are passing two arguments. One is this data, and one is this column names. Okay. Now what will happen is that we wanted to see the data frame. So we have written data frame.show. If we want to see the schema, we have written data frame.print schema. After that, what happened? One data frame got created, which is having two columns, rows and description. The rows, whatever we have, mentioned, let's suppose data analyst, and whatever the descriptions are there, let's suppose analyze data, all those things, descriptions are shown here. And similarly, guys, one data frame got created. This is how we are creating a data frame from a list. Tell me, guys, any more doubt? Are you now in a position that you can, create a data frame from a list? Yes or no, guys? What is the way?
So Vikram, where we are, getting this app name while after the execution,
Yeah,
the
we
Python
will get
Spark,
it in
PySpark.
the, let me just, show you that also. Just give me, guys, one second. This is called, guys, host 4040. Okay. So let me just, guys, go to that particular, page. So this will but execute, at the time it will, execute this particular code. That time only you can, see it. Let me just, click now. Nothing will get, guys, executed. The site cannot be reached. Let me just, make it small. Now let me just, execute this particular code. At the same time, let us just, refresh this page. Yeah, see here. So you got that Python PySpark example. This is what we are creating, guys. Python PySpark example. So this is what internally, you can see in the local host, 4040 jobs. This is the, Spark session which has got created, and which is the, environment it got created, which is the stages, which is the, but as soon as this code will get executed, guys, then it will abruptly, close. Are you able to see, guys? Let me just execute again. Okay, let me just execute again, and let us just, paste this, localhost 4040. Okay. Yeah. So you got this, Python, PySpark example. This is internally getting created in this Spark session. Any
So
doubt,
here
guys?
only
Here?
we will see the execution status. Right?
Yeah, you can see
Cluster, all
the
this.
executors, the SQL, data frames, whatever you want to see. But there's a very, limited time frame, because if it will get executed, you cannot, see. But I showed you, right, where this Python, PySpark example is getting created. You have to use this, you
Got
guys, URL, this one, localhost 4040, and you have to execute this. And when you are executing, that time only, you have to click on this enter, because at that moment only it will, execute. Once it has, executed, you cannot, see. So let's suppose which are the executor. So these are, guys, active, dead, and total, executor, everything you can just, see here, which is the, environment, and all those things, guys, you can just, see as long as this particular code is getting executed. Once it is executed, you cannot see. Tell me, guys, any more doubt?
But still we can see the history, right? And
Yeah,
particular,
yeah,
app
yeah, you can,
after the
but
execution.
no, but this page only, goes completely, abrupt as long as the execution is stopped. If you want to see, guys, the problem is no. If you want to see, you have to, see at the time of, execution, because Spark, once Spark has executed, then there's nothing, left. Now
No,
you
in
can see.
companies, actually, in the history also, they were seeing comparing the previous execution and
Yeah, you can
apps.
do in your company, but this is here we can see guys whatever things are there as long as it is guys executing.
Okay.
Guys, tell me any more doubt? Can you create a Spark? Create a data frame now after this many questions? Yes or no, Juhi? Tell me. Susmita, can you create a data frame? What is the actual method? Tell me. What is the actual method, guys? Everyone, tell me. Create data
Create
frame.
data
Spark dot
frame.
create data frame. Do you guys agree with me? First, we'll
Yes,
create
sir.
a Spark session, guys. Okay. How to create a Spark session? More than 10 times I have told you Spark session.builder.app name, whatever app name you want to get, dot get or create. Import this Spark session for PySpark.sql. Give the column name, give the data. Formula is what? DF, whatever name you want to take. I have taken DF equals to what? Spark dot create data frame, pass the data and column name, and then show. Can you guys now create a data frame based on the list? Tell me, guys, yes or no?
Yes, sir.
Now at least you can create, guys. Yes or no? So now, guys, this is what a simple, data frame from a list we have created. Okay. So there's something called as a row object. What is a row object? A row in a PySpark is, like a dictionary of records in a table. A row object, guys, first a row will be written. And then, dictionary has key and value, ID equals to 1, comma, name equals to Alice. This kind of structure is called, guys, a row object. Okay. So you can just create a, data frame from a row object. Let's suppose this is a data which is given in a list format. Row, comma will be there. And then, key value will be there, key value will be there. Let's suppose, we want to, create a data frame from here. So we can just create from here also. Let us just, try to, I'll show you many ways to create a, guys, data frame, so that get your brain and mind gets adjusted to creation of a data frame. Let's suppose from a row object we want to create, or from somewhere else we want to create. So from PySpark.sql we have imported the Spark session, and we have also imported this row, guys. And then we have created a Spark session, Spark session.builder.app name, and then row list to data frame dot get or create. This is just creation of the Spark session. Then we have created a list of row object. That means this is our, guys, data. Okay, what is the data? So data is, guys, row ID, row, then the key value ID equals to 1, name equals to Alice, age equals 25, like that it is there. And then what we are doing, we are using, guys, a Spark.create data frame, and we are just pass this, guys, data. And then we want to see this, data frame, and we are able to see. Any doubt, guys? Creation of, data frame from a row object. Any doubt, guys? Tell me.
So to get the data by the rows, we have to giving the row before this.
Yeah, no, this structure is only like that. That first the row is written and then key value. That is called as, a row object.
Okay.
Yeah,
Vikram,
Vikram, as
where
a
we are
tester,
saving this data frame?
Where we are saving. No, it is going in, CPU in that RAM for a temporary basis. We are not storing anywhere. It is going in a RAM for a temporary basis. If you want to print, in a particular file and all those things that we will see, guys, there's something called as, when I teach you Python, told you write method, read method, if you remember file handling, and we can, write it in a file that we will discuss. But as of now, these things are gone in a RAM. Tell me, next out, guys. Tell me.
Vikram, as a tester, we are going to create it or we will be testing it?
Definitely, you will create it. Let's suppose there is a source in Excel file and target is a Oracle. That time, who will create the source and target, and who will compare that? This time this is just, example I'm showing using, list and, using row object. Let's suppose, there's a CSV file. Let me just go. Oh, forget this pandas. I'll come to the panda, but let me just, I just want to, yeah. Let's suppose there's a, a file, emp.csv. Okay. Employee table. These are the data, guys. And let's suppose I want to, create a, a data frame from this file. Okay. So what I will do, let us just first create it. Okay. See, from PySpark.sql, we have imported the Spark session, guys. What is the Spark? How we are creating? Spark session.builder.app name and then .get or create. These things I have told you so many times. Let's suppose this is a CSV file. Okay, this is a CSV file. In this path, I have kept it. So what I will do, spark.read.csv. There's something called spark.read.format.load. That method also I will tell you. Using pandas also I will tell you. All the methods I will tell you one by one. Okay, let us just, we are reading a simple CSV file. This is exclusive for CSV file. So what I'm doing, spark.read.csv, and then just give the path, guys. Let's suppose you go right click and you just click on copy path, absolute path, and just, let us just take this path. But in Mac system, double, slash is not required. As long as you are seeing this, Windows, you have to give this, path, guys, like this. Okay, whatever the path is there. Okay, keep this path, guys. Okay, and then what will happen? This path, where you have to give here, you have to give this particular path. Okay, and then what you have to give, guys, if you want to see the header, this means this first record, you give header equals to true. If you want to see the schema, guys, you have to write what infer schema equals to true. So if we write all these things, guys, and then we do a data frame dot show. So let's suppose you see here. It's telling me the schemas. Yes or no, guys? If you don't write, this infer for schema equals to true, then what will happen is that everything will be taken as a, string. Let me just, show that also. Let's suppose I don't give this, infer schema equals to, true. Then what will happen? As of now, I'm getting the schema, employee number integer, ename string, job string, manager is integer, hire date is string, salary is integer, commission is a department number is integer. Let's suppose I have removed this infer schema equals to true. And then I am, executing this, particular code, and I want to, see the schema, and I have written df dot, print schema. So now what happens? Everything is now, guys, string. Employee number is string, and then ename is string. Everything is string. So we are not getting the correct, schema. If we want the correct schema, we have to write infer schema equals to true. And let's suppose I don't write, header equals to true. Then I will not get this first record, guys. Let's suppose, remove this header equals to, true. I will not get this first record. Let us just, see that. So if I don't write, header equals to true, I will not get, guys, this first record. That will again, not look, good, kind of data. It will look like, C0, C1, and then underscore C2, C3, C4. Now we have to understand, guys, we can select that C0, C0, C1, but, again, this is not the, optimized way to see the data. Now, and then if you want to see the correct way, then you write all the things, guys. You write that, you write here, header equals to true, so that you get the correct header. And also you write, guys, infer schema equals to true, so that, you do not get everything as a schema. Now, if I execute the code, now this is my source. Source is a file. Target is also file. So let's suppose we want to get the, schema of the source. So I've got it. Yes or no, guys? Integer and then string and all those things. And here we are getting, this the particular data. And later I will show you, I will create a, target also. And then, guys, what will happen? I will start comparing, and that is what is the ETL testing. So we will see that, guys. So this is what is the thing, guys. Tell me now, Juhit, is your question, answered that why we need to create a data frame?
Yes. Yes.
Guys, this is how we create from a CSV file. Any doubt, guys? Tell me.
Vikram, their integer, their data types are there. It already taken, or you already gave that data
No,
types?
I am not doing it. It is taking by itself, whatever, schema it wants to take.
Okay.
It Spark actually, guesses the column type based on the file values. Okay. It thinks the file value, employee number is 7369. So Spark will guess it is an integer. Okay. This is who is guessing this? We are not guessing it. Who is guessing this? Spark is guessing. Yes or no? Tell me. See, even for, the guessing is for, higher date, it is guessing it as a string. Actually, it should be date. Yes or no, guys? But, Spark will not, treat when you are using this CSV method. Spark will not take this, higher date as date. Okay. So that is what it is. It has guessed it as what, guys? As a string only. Yes or no, guys? So this is the guessing done by what? By the Spark. We don't have any control on that. Because, Spark, for the CSV method, it understand, guys, int, double, string, integer, this kind of things. Tell me, guys, any more doubt? Now, guys, if someone will tell you your source is a file, target is a file, just check the data of the file and source and target. So can you check that? Yes or no? Let's suppose take let's suppose create a guys a target also. Okay. Let me just guys paste it. Let's suppose I am writing it guys underscore t. This means it is a target. Okay. This is your target and this is your source. Okay. So let's suppose we want to see the data. So what will happen? So of the target, if I want to see, what will happen, guys? Tell me. What will be the code written here? What will be the difference, guys? Path and all is same. Underscore what we have to write. T, yes or no, guys? This is your target. And then let us just execute it. So let us just see how many outputs are coming. This is for which one, guys? Source, data frame we want to see. This is source schema we want to see. This is target, data we want to see. This is target schema we want to see. So we can, manually now compare. I'll tell you the formulas how to calculate. But as of now, manually we can calculate. Yes or no, guys? Any doubt here? Tell me, guys. Any doubt?
So
Vikram,
writing
what
into the
if we
target
don't
also.
give?
Yeah, tell me. One by
What
one.
if
Yeah.
we don't give print schema?
Then how will you see the schema? How will you see the schema? This is the
Then
formula,
what?
right? In SQL, how you see the schema? Tell me. If I go to
No, I
SQL
thought
development.
show is.
No, show will show the
show
data.
is.
Show will show the data. Schema, you have to write print schema. All of you are good in SQL, I assume. What about everyone? All of you are good in SQL. Yes or no, guys? No one is telling. Huh?
Yes.
Are you
yes.
good in SQL, guys?
Yes, Vikram.
Let me just see. I am connected to that on it. Let's suppose this is the table, guys. EMP. Okay. And we want to see the schema. That means the structure. What is the code? DSCAMP. Do you guys agree with me? Description of the table will give the structure. Yes or no, guys? Yes or no, guys? Do you guys agree with me? The number, the data type. Yes or no,
Yes,
guys?
sir. Yes.
Yes or no, guys? This is how we see. And here, what we are doing? Here we are writing, df.print schema, somewhat similar to, guys, schema SQL. But I will be keep, comparing you. Yes or no, guys? But it's not, entirely, we cannot tell, entirely, you guys, the SQL, but somewhat similar to SQL. Tell me, guys. Tell me any more doubts.
Is it
Yeah.
writing the source data into the target? The method read is the same as the
Read. We are now just seeing the data. With that read and write file handling, I will tell you later. As of now, we are just seeing this read and write. Okay. How to put it in a file and how to get the result.
read is existing. Okay, read, but here you're loading the source data into the target, right? There also it is coming as a read only before writing.
We are just copying and pasting. You take a CSV file, take my file, okay, and just
Okay.
copy and paste here. I'll share you guys this entire
It's not
code only.
writing; it's a copying.
Yes, it's a copying. You have copied from let's suppose go to this Explorer. This is a file. Okay, let's suppose I give you this file. So what you will do? Right click. What you will do? Copy,
Yeah,
and then
copy
you will go to
paste.
this particular path. This is the folder. Right click, and then paste. Yes or no? And then let's suppose I write emp underscore 3. Yes or no, guys? So this is what is getting tested. So here it has come emp3. Tell me. Are you getting some clarity, guys? How to create a data frame from a particular file? I'll give you this folder itself, guys, so that just practice that and just try to create a data frame and do this, guys. Make make things very very simple, guys. Okay. Let me just give you guys this let me just put it in a
GitHub.
the 7-zip. Okay, let me just zip it. Okay, and then let me just give you in WhatsApp. Guys, don't please share